Greetings everybody, welcome. This is for the 8-bit retro community. So if you're here looking for gaming or free energy, this isn't the video for you. But stick around and give it a watch. Maybe it'll interest you. So, I've been looking around the 8-bit community for a while, watching videos, watched the stuff from SM Baker on the RC 2014 and various others, the 8-bit guy, some of the stuff that he's been doing, and a load of other people off the top of my head to do with Amiga repairs, BBC repairs, Spectrum repairs, so on and so forth. Now, I was brought up on the Spectrums at home. At school, I was brought up with the BBCs and loved them both. Never really appreciated what either of them really were, if I'm honest. I mean, by comparison now, Spectrum versus BBC, yeah. I really wish that I'd been brought up on the BBC, especially the Master. That is some impressive piece of kit, even by today's standards. Really wish I had one. But anyway, don't have one, and I'm not going to fork out like £150 for one. Instead, well, when I was at school, 14, 15 years old, that would be like 25 years ago, I was given a Spectrum 48K servicing manual which had the schematics in, and with the exception of the video circuitry, which is way beyond me, I could actually understand how the processor talks to the RAM and so on and so forth. So now, as I said, about 25 years later, I understand a lot more, and I still have this urge. I want to make my own computer. I can't remember who it was that I was watching, and forgive me, people will probably recognise it as soon as I say what the videos were about. But it was about making your own 8-bit processor. And I've got the videos saved and bookmarked, and it's like, yeah, you know, that is quite interesting to me. So I want to build my own computer. Now, I could build one of the open source ones that are out there, the RC 2014 for example, but there's something else that I want to do in mind. Forgive me for all the chatting, hi by the way. This goes back to the 8086 era and the 286 era. And even the Spectrum was thinking about it. They all have inefficiencies, and I hate inefficiencies, especially in computing, because we now have processors that can do 4 gigahertz, and it's like, why is it still slow at 4 gigahertz compared to what I was raised at? with 1 and 2 megahertz processors. 64-bit processor running at 4 gigahertz. It should be able to do everything a lot quicker. So then you wonder why, and it's to do with all the inefficiencies. Going back to the 8086, the interrupt controllers needed more interrupt lines, so they stacked an interrupt controller on top of an interrupt controller. Good call. That's one way to solve it, and it's still there today. Today's PCs are backward compatible to the 086s. The DMA controller, they did exactly the same thing, and today's PCs are backward compatible. Today's PCs, because of money saving, uses dynamic memory that is a lot cheaper, and it's also a lot slower. Not only do you have hardware that sorts out the row address strobes, column address strobes, etc., but you also have to refresh the memory as well. And it's like, really? People want faster PCs and you're using memory that's inefficient? Okay. Well, I want to design a system that gets rid of all the inefficiencies as possible, but also runs quick. And maybe this will catch on in the community. So I want to do an initial project video. That's what this is. So I've got a piece of paper, I've got a pen, and so let's throw some stuff down. It's in a socket. Hopefully, I've only got a small preview window, but hopefully that's actually reasonably well focused. But that is a Z180. It's a 33 megahertz Z180. So that's what we're using. My handwriting sucks. Not only that, but my camera's upside down, so I'm actually viewing the preview upside down. I will try and flip the video for upload to YouTube. So at 33 megahertz, each cycle is 30.3 nanoseconds. Okay. So let's do this in a simple sort of way. One ruler, and we're just going to put in a straight line for our bus. Let's assume that is our backplane. So you got the Z180 here. And it connects onto the backplane. There's your processor. Now the Z180 has a load of hardware on board, comms, etc. We're not using it. Now there's a reason for that. It might be designed to run at 33 megahertz, but I'm hoping to go faster. Basically, we want a system that is fast and efficient. So I'm going to be pushing the hardware. So we're going to be taking a leaf out of the PC book, or the PC design for this. Now normally in the retro community you have ROM and RAM on the address bus. I'm not going to do that. I'm going to have one megabyte of RAM straight on the bus. No ROM, just RAM. Right. Now I'm looking for a 1 megabyte times 8 chip. Haven't seen one yet. The reason I want one single chip is there's no glue logic there. Glue logic will slow it down. So ideally, well, that being said, I can use 8 lots of 1 meg times 1 chips and that won't cause a problem. Or any slowdown. Or a 1 meg times 8 chip. But if I have to use 2 chips, then I need glue logic to select which chip the memory is actually going to. So the Z180 can physically address up to 1 meg, but the processor inside only sees 64K. That's fine. The Z180 has the bank select built in. So the next question you're going to ask is, how does the CPU get its software? Because with that system there, on boot or reset or anything like that, it's going to be completely blank. The RAM is going to be an unknown state. Well, here comes the funky bit. The storage array. I have these. Yeah, you're gonna wonder what the heck they are. And I can't actually read them right now. These things, that's the Z180. These things are dual port static RAM. They are 8 kilobit dual port static RAM. So it means that the RAM can be accessed from 2 sides. Oh, B. So 8K dual port RAM. So the A side connects to the bus, and the CPU is going to write these devices on its I/O bus, not the memory bus. Its I/O bus is 64K. These are 8K chips. We can select which card. We can have 8 cards in, and we can select which one we're writing through down the I/O bus. So these are I/O mapped memory, not memory mapped I/O. They're I/O mapped memory. So from that, we're then going to use wow, my brain's just gone blank. Right in the middle of a video. 46K22s. What are they? They are the PIC 18 46K22. They are microcontroller. They run at 64 megahertz, well, up to 64 megahertz with their onboard clocks. So we're going to set this one to read and write to the dual port RAM on the B port. Right. And it will then talk to SD cards. That still doesn't answer the question as to how we're going to get any software from the SD card into RAM. Well, we're going to need a watchdog module. Regardless of what we do, we need a watchdog module. So we're going to use another 46K22, and its job is very simple. When we first power up the system, there'll be nothing on the SD card, nothing in the RAM, so it has port for PC debug. So we can download software from PC into this watchdog, and the watchdog can then send commands to the storage controller, that's this thing, and write the image to it. So it will hold the z180 in reset, so it goes to Z state, and we can then write the image from PC into the SD card. Now, when we've got software on the SD card, a kernel image, right, and we start the system up, the watchdog holds the z180 in reset, sends instructions to storage 0, whatever you want to call that, and storage 0 loads the kernel image into the 8K dual port RAM, and then the watchdog transfers it into memory, and then it releases the processor, which then starts running it. Simple, sound like a PC loading from hard drive, maybe? Sounds like a plan. Makes everything to do with memory a lot simpler. No glue logic, so it means it's faster, more reliable, less things can go wrong. So what else can we do on this system? What else can we plug in? What else do we need? Well, Z180 has COM ports on there, serial ports, but we're not going to use them. Now you could say why? Because we're going to offload as much of the processing from the CPU as possible. So we're going to have comms card, and again we've got 8K dual port RAM. So when we're sending stuff or receiving stuff from the serial ports, it'll go into the dual port RAM, and then we read it from the processor at full speed. So to control this, another 46K22, and the 46K22s have hardware comms built onto them. 2 of them. So we're going to call it COM1 and COM2. Now, COM1, guess what? That's going to be our terminal. Now, COM2. What can we do with COM2? Well, perhaps I should say what can't we do with COM2? How about we hook it up to a Bluetooth module? And then maybe from the Bluetooth module we can use a Bluetooth keyboard for direct input. Does that sound good? So if we didn't want to have another PC on to access the terminal, we can use a keyboard attached to the Bluetooth module and any other Bluetooth device, maybe. Sounds like a plan. What else can we have on here? Well, the 46K22s can write to certain LCD displays, so we could have displays hooked up, but they do require quite a lot of I/O lines if they're not an SPI connection or an I2C connection. Which also reminds me, the 46K22s have dual SPI or I2C hardware on them as well. So we could have I2C lines on what would effectively be the comms card. Sounds like a plan. Depending on how much I/O I've got left after we interface to the 8K dual port RAM. So we could have display card in on here as well. What else can we have on? Well, honestly, with this system, we can access 8 lots of this dual port RAM. So we've got space for 6 more cards. So, well, most people will want to have sound on their systems. So, yeah, there's no reason why we can't have a sound card on here. And just digitize everything into the 8K dual port RAMs. Certainly got enough of them anyway. I think I've got either 5 or 6 of the dual port RAM chips. Now, as I mentioned, these cards are I/O mapped memory. The Z180 does have DMA capabilities, which can transfer from I/O mapped memory into memory mapped memory. So at some point, we could do some very rapid transfers from the hard drive into main memory and from memory out to another card for high-speed comms or high-quality sound. Whether a 33 MHz bus is going to be able to support some of the more data-intensive audio is another question. But at 33 MHz, that sounds like PCI. And that could certainly support quite a lot of hardware. But the problem with PCI for computers was that its address and data lines were multiplexed, and we're not doing that on here. We're having separate address lines, separate data lines, separate control lines. So we're keeping everything separate. That is the idea. Because I looked at getting hold of either a PCI or ISA graphics cards, and yeah, interfacing a Z180 to one of them just on the electrical side was going to be a real pain in the butt, just because of the multiplexing between address and data lines. I hate that. So keep it simple, and hopefully we'll get an efficient system. So software, there's nothing that I know of that would run on this, so everything has to be designed from scratch. All the OS, everything. That could get interesting on its own. So these 46K22s are acting like what were they called? The manufacturer's own sort of chips, like the Western Digital ones for IDE, so on and so forth. So with those 46K22s, we can do anything with them. Programming them is not a problem. So whether it's to talk to an SD card, act as comms handlers, we can do anything. So while yes, this isn't really purely retro, it's not a pure 8-bit system, because the 46K22 is a RISC microcontroller that's 12 bits. I think it's a 12-bit microcontroller off the top of my head. It does emulate sort of what the manufacturers could do back in the day. So as I said, 46K22s are 64 MHz, up to 64 MHz by their onboard clocks. I have had one running at 100 MHz. So we can make them go faster. They've got their own onboard flash, onboard RAM. They do have EEPROM, or EEPROM I should say. So seems a very simple design. I'm just at the initial sort of stages. I do have some hardware chips. I'm basically looking for sort of ideas being pointed in the right direction. So anyone that wants to comment, feel free. I would love to see what you guys sort of make of the idea. So feel free to leave comments. Don't expect weekly videos, because it's taken me a year, I'm going to say, to get to this point. But one of the things that I do want to do with this type of system is to be able to swap out the processor. So while I'm going to start with the Z180, maybe down the line I'll swap that out for, I don't know, 6502 or 68K, any type of processor basically, provided of course it interfaces with SD-RAM, not DRAM. So comment, subscribe, don't forget to hit the bell, and well, maybe this is something that I'll make open source when I actually design it. But one of the other things that I want my own system for is to be able to program the PIC32s, well, PIC24s and PIC32s, and to make something a little bit more powerful. Maybe go up to the ARM Cortex processors. Maybe something like that. So I want my own compiler on here and whatnot. So hopefully that sparks people's imaginations. Throw ideas at me. I love to hear them. Hopefully I will hear from people soon. Bye for now.